we're going to work on the quiz for the second quiz for Chapter 12, and that's found on page 836. Okay. All right, number 1 says find the volume of the figure. Now, if you look at your theorem list, you want to find the volume of a cube, the volume of, the volume of a prism. We're looking at a prism, a triangular prism, and it says the volume of a prism is the big base times the height, where B is the area of a base. When they say base, they mean the figure that the three-dimensional figure is sitting on. Okay, so that would be this triangle, because it's important that you imagine that the base cannot be, for instance, this square, because if it were that square, then if you set this up like this, the base can't be, wow, I didn't draw that right. There we go. The base can't be that square, because as you would slice this, the pieces would get smaller and smaller and smaller. They'd be similar, but this is not a pyramid, and you can only find the volume of pyramids that way. Okay, so it has to be on a surface or on a base that as you slice through it, you're going to get a bunch of triangles that look exactly the same. Because what you're going to do is find out how many cubes will fit in that triangle. And then you're going to multiply that by the number of layers you have. These layers wouldn't have the same number of cubes in them because they keep getting smaller. The first one would be normal size, and then they would just get smaller and smaller as you went up the figure. Okay, so just to explain how that works. So the volume is equal to the big base times the height. You have to find the base that has an exact similar or an exact congruent figure on the other end of it, and these two triangles make up the bases. Okay, so you just want to find the area of one base and then multiply that times the height of the whole thing. So if we draw this triangle, it's a right triangle, and we can find that the bottom of that right triangle is 10 centimeters, and this side is 15 centimeters. Now, I kind of bent that a little bit, but you get the idea. All right, so the area of a triangle is equal to 1/2 the little base times the height. Now, little base is a line. Okay, big base was actually a figure. So the little base times the height. So that would be area of the triangle is equal to 1/2 of 10 times 15. So we can cancel that 10 and that 2, and we get 5 times 15, which is 75. So the area of the triangle is, and I'm just going to double check it, 1/2 times 10 times 15 is equal to 75. All right, now we're going to take the area of that big base and multiply it times the height of the whole figure, which is 7 centimeters. So 75 times 7 centimeters, and this is centimeters squared, by the way. And then this will be centimeters squared times centimeters. So times 7 is equal to 525 centimeters cubed, because they are cubes of centimeters. All right, going on to the next figure. Again, volume is equal to the area of the base, or big B, times the height. So we've got to find the area of this circle. And the area of the circle is pi r squared. And since r is 6, that'll be 36 pi. Now if you want, you can wait to multiply through by pi until after you have multiplied by the height. So we've got 36 pi is the area of the base, and then we can multiply that times the height and get 360 pi. And then we can multiply 360 times pi and you get 1,130.97. The 7 bumps the 9 up, and the 9 bumps the 0 up, so we get 1131. Or, well, that works. Okay, you also could have had, you could have said 36 pi and you would get 113.09, which would be 0.1, because the 7 will bump the 9 up. Then multiply that times 36. Times 10, because that's the height. So you have 113.1 times 10, and that would give you 1,131 exactly. Okay, now the important theorem to remember for this one, let's go over and take a look at our theorem, is that one about slanted slanted figures or slanted prisms. It says if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. Okay, and what that means for us is that if this leaning cylinder would have the same volume as a straight up and down cylinder that has a radius of 9 and is 16 meters high. So we're going to work it the same way. The volume is equal to the area of the base times the height. So we find the area of the base. Now it tells us 9, but we can't really tell what the 9 is referring to. Well, since the 9 is in the middle, so I'm really careful with you guys when I do this. Since the 9 is pointing to the center of the circle, it appears that the diameter is 9 because the line goes all the way through. And I didn't draw that over here that way, but anyway, try to figure what they're pointing to. That would give it a radius of 4.5. It doesn't look drawn to scale because this is 16 meters, and if this is 9 and that's 16, 9's only going to come to about right there. So 9 and 9 is 18. Anyway, don't worry about that part because they don't have to draw it to scale. We've talked about that before. A lot of times they make it deceiving for you. Okay, so we're going to find the area of the big base. Base is equal to, area, the area of that circle, is equal to pi r squared. And r, if the whole thing is 9 meters, then r is going to be 4.5 pi squared pi. Okay, 4.5 squared is 20.25. And then multiply that through by pi. 63.62. And that's going to be in meters squared. That's the area of the big base. Then, since volume is equal to the area of the big base times that height, times the height of 16, multiplied by 16, and we get 1,017.88. Okay, and that is the way they worked that. Now, if you write out all of your work, and to you look at that and think that looks like that's 9, and if you had made that mistake, if you're writing out all of your work, I can give you credit for that anyway, because I would see what you were doing. Okay, moving on to the next one. We're going to be working with pyramids. All right, so we want to go look at our theorem list and figure out how to find the volume of a pyramid. That's the surface area. Make sure you get the right one. The volume of the pyramid is 1/3 the base times the height, where it's the big base again, so it's the figure that makes up the part that the pyramid is standing on. So whatever shape that is, you might have to use, you might have to find the area of a polygon in that case. But in this case we have a square, and so 1/2 volume is equal to not 1/2 but 1/3 the base times the height. Okay, so the volume of the base is, the area of the base, the area of the square, is equal to side squared, or 9 centimeters squared. Okay, then we've got to multiply that by the height. So volume is equal to 1/3 the area of the base, which is 9 centimeters squared, times the height, which is 2 centimeters. Whoops. Try that again. Okay, so we can cancel our 9s, our 9 and our 3. And we get 3 times 2 is 6 centimeters cubed. Okay. Go back and look at our theorem list for the cone. The volume of a cone is also equal to 1/3 the big base times the height. Okay, so the first thing we have to do is find the big base. Again, we have 60 feet referring to the entire diameter. Half of that is the radius, which is 30 feet. So we would say the area of the circle is equal to pi r squared. R here is 30, so 30 squared times pi. I always turn it around that way because it seems more normal than to say pi 30 squared. You also don't want to accidentally multiply pi by 30 first and then square it, because that doesn't work out so well. So 30 squared is 900, and 900 times pi is equal to 2827.43. And that'll be in feet squared, because it's feet times feet. All right, now up here we have, we're looking for the height. I'm going to move all this stuff out of the way so I can see what I'm doing. Okay, we have the slanted height here. So we have a right triangle here. And this is, if you're careful, you might recognize this is a 3, 4, 5. Actually, it probably is not. Never mind. Let's see. So this should be a squared plus 60 squared equals 50 squared. Or we can go ahead and subtract our 60 squared from both sides and get a squared equals 50 squared minus 60 squared. Oh, that should be 30. It is a 3, 4, 5. Beg your pardon. Okay, 30 squared, and there's 30. I just left that 60 there after I erased. See, I can make the same mistakes at home, but I don't have you here to correct me. Oh, gotta fix the last one. Minus 30 squared, but we already know what it's going to be because it's a 3, 4, 5. We already know that's going to be 40. So, since the volume is equal to the area of the big base, the area of the big base times the height, we get 1/3, and the big base is 2827.43, and then the height is 40, so times 40, and then divide by 3 equals 37,699.11. And that's going to be in feet cubed. Okay, now remember the reason this is 1/3 is because as you're going up the height of your pyramid, your squares are getting progressively smaller. And that's going to be at a ratio of 1/3 by the time you reach the top. Same thing is true over here. That's why we have the 1/3. Okay, looking at the last one, which is a funny slanted cone. Says if two solids have the same height and the same cross-sectional area at every level, then they're going to have the same volume. That's Cavalari's principle. Now look over here. This pyramid, whether it's standing up straight or whether it's leaning, is still going to have the same size circles at every level. So we can use the same formula. All right. So once again, the volume is equal to 1/3 the area of the big base times the height. And what is the area of the big base? The big base is equal to pi r squared. And r in this case is 8. It's already found for us. 64 pi. I just went ahead and squared it. 8 squared is 64. So 64 times pi is 201.1. yards squared. The volume is going to be equal to 1/3 the 201.1 times the height, which is 15. So multiply times 15 and then divide by 3 and you get volume equals 1005.31. There's 0.9 that rounds to 3.1. Show all your work. Makes it easier for me to give you partial credit. Alright, suppose you fill up a cone-shaped cup with water. You then pour the water into a cylindrical cup with the same radius. This is R, and this is R. They're the same. I don't like the way that R looks up there. Okay, now the question is, you then pour the water from this cone right here into a cylindrical cup with the same radius. Both cups have a height of 6 inches. Without doing any calculation, determine how high the water level will be in the cylindrical cup once all the water is poured into it. Well, remember that the volume of this one equals 1/3 the area of the big base times the height, and the volume of this one is just equal to the base times the height. So if we filled this cup all the way to the top, it would be filled up with 1/3 of what that would be. So it says, how high would the water level be in the cylindrical cup? Just 1/3 of the distance, and 1/3 of that 6 would be 2 inches. And the reason is, the question is why? The reason is because only 1/3 of this volume, of this whole volume here, will fit into that cup once you've turned it into a cone.